Good morning, good evening, or good afternoon, whatever time you're watching this resource video about accuracy and precision. These two terms are very crucial in physics, especially in dealing with measurements. All right, so let's try to find out what's the distinction between accuracy and precision. In terms of reliability of measurements or how good or how, let's say, accurate or precise the measurements are, it can be described by these two terms. We have accuracy and precision. Let's get to know first what accuracy is. When we say accuracy, the best definition is that in measurement, it show that the data is or are closer to the result, or it's how close your result to the true or the accepted value. For example, the accepted value worldwide about boiling point of water is 100 degrees Celsius. So if your measure, if if you try to get the measurement of the boiling point of your solution and it gets to that particular value or close to that particular value, then that result is, or that measurement result or measurement's reliability is accurate, especially high accurate. And when we say accuracy, we can incorporate the dart word, and the dart um, represents your measurement or your, let's say, data. And if you notice, the bullseye there represents the accepted value. And all the darts, are close to that bullseye. It means that this data or this measurements are accurate. Okay. And then when we say precision, on the other hand, in measurement, it refers to how consistently you get the same result to each other when you repeat a measurement under the same condition. It's all about repeatability and consistency, but it is not always correct. It is not always the right value. Okay? But always remember, all these measurements are grouped together, closed together. Let's say, for example, I have your picture where, yeah, let's go back to the basic. The bullseye is our accepted value. And then the measurements or the trials you've done, all the values falls to that area of the dart board. It's precise because the data, or yeah, the numbers are close together. Yeah, but it is not necessarily the correct or the accepted value because this are, I mean, this data or the numbers or the trials, the results are far from the accepted value. Okay. Example of precision problems that usually, you know, used by teachers. To show precision, let's say you measure the length of a desk 5 times and get 98.1 centimeter, 98.0 centimeter, 98.1 centimeter, 98.2 centimeter, and 98.1 centimeter. Those results are tightly grouped. From the word itself, tightly grouped, meaning to say it's precise, right? The precision is very high in this case, very close together, right? 98.1, 98, 98.2. And of course, since you measured it 5 times and you got this closed, let's say closed uh, value, so it means that this is also high in accuracy because you measured it 5 times and you keep on measuring this results closer to 98 if you will get the average. So this situation depicts high precision and high accuracy. Another example, we have this. Someone else gets values like 95 centimeter, 199.5, 98.6, and 101 centimeter. And they may average close to the actual value, but their results bounce around. If we analyze the situation here, there's a there's a phrase, I should say phrase, may average close to the actual value. So in that case, it's accurate, right? It's accurate because it's close to the actual value. The average might be close to the actual value, but the results bounce around. So it's not tightly grouped, but it's bounce around. So it's this situation shows low precision and accuracy is high. Okay, when we talk about precision, I have another problem here. Think of a stopwatch that gives you the same reading every time you record a race, even if it's off by zero point 0.5 seconds. So as you record um, the race several times and you got the same reading, even if it's there's something off with the stopwatch itself. And in this case, I want you to guess what's going on with the precision and accuracy of this situation. The answer, precision is high because you keep on getting the same and close results, right? So they are gathered together. Precision is high, but the accuracy is not anymore high. Why? Because the stopwatch itself it is being off by zero point 0.5 seconds. So there is really um, the value being given in that stopwatch is not really accurate. So it has a low accuracy. In terms of accuracy problem, we have this. Imagine you're timing how long it takes water to boil using a digital stopwatch. The verified time for water to boil is at 5 minutes under a controlled setup. So it's in the method is that it's being controlled. The setup is definitely controlled well, and they use in digital stopwatch. And it stated also that the time for water to boil is 5 minutes in this controlled setup. You run the experiment 5 times and get the following results. You have 4.98 minutes, 5.01, 5 minutes, 4.99 minutes, and 5.02 minutes. The data is close to each other for sure. The precision there is high, right? They're close to each other. And when you get the mean or the average of this samples here, um, yeah, it's close to each other as well. So in this case, accuracy is high as well as precision. Okay. And we have shooting arrows at a target. If three arrows hit right around the bullseye, even if they're a bit spread out, but they're close to the true mark. What do you think is the measurement's reliability here in terms of accuracy and precision? Three arrows hit around the bullseye, even if they're a bit spread. The word there is like bit spread. So they're not really close to each other, right? And yeah, but they're close to the true mark. So that's high in accuracy, but low in precision because when there is really this word, I want you to bear in mind that if the result is like spread out or slightly different, okay, yeah, it's a low precision because when we say precision, they are close together. The data is close together. The samples are close together, although it's not true all the time, right? Away from the accepted value. But in this case, it says that they're close to the true mark. It's high accuracy, on the other hand. Okay, I hope you get it well. Thank you. And now I have one more problem, I guess. in terms of accuracy. Suppose the actual temperature is exactly 37.0 degrees Celsius. That's the actual, the accepted value. And then a clinical thermometer gives these readings over several trials: 36.9, 37, 37.1, 37.0, 37.0 in degrees Celsius. It's very clear that this sample readings um, high in accuracy, and they're close together. The data, or the degrees in Celsius, are close to each other, so it's high accuracy and high precision. Okay, and then you place a standard 1 kilogram weight on a digital scale, and it shows 1.01 kilogram, 1000 kilogram, 0.99 kilogram. The average is still around 1 kilogram, close to that accepted value, the standard 1 kilogram weight on a digital scale. And it was agreed that the weighing scale can be utilized in weighing 1 kilogram object. So in this case, high accuracy and high precision. The data is close to each other, not spread or not randomly spread. They're close together, and the mean or the average is close to one. So high accuracy and high end. So I will be presenting to you factors affecting precision. The first one, we have measuring device used. If we are using an old apparatus in doing our experiment, it will really affect the precision, or how consistent or how close your values or your measurements, okay, while using that device or apparatus. That is why before doing the experiment, you really have to recalibrate every apparatus you're using. Especially, you have to check the calibration, if it's clear, visible, or easy to observe. And for example, you're using let's say balance scale, really have to set it to zero before you will do the experimentation. Manner of measurement. The manner of measurement, for example, all of the sudden you measure a certain distance or length of a certain matter, okay, use in your experiment or whatever. And then the position of the angle, uh be, the angle you observe is, prone to getting unrealistic or unreliable measurement. So that will also affect precision. Okay, that kind of instance is very common, especially if the time is very limited and then you measure something, you're pressured by the time, so you gotta quickly measure the length of that object, and the position of that um, measuring tool is inappropriate, plus the angle upon observing. Okay. And condition of the environment during measurement, it's very common and it's unpredictable because, for example, you are measuring the time, how long it takes for this solution to boil in a supposedly controlled environment. In order for you to achieve a precise, or let's say accurate measurement or data, of course, the the environment should be like constant. The temperature around is constant, but sometimes we cannot control it. It's inevitable because at times weather will abruptly change from that um, degree, and then sometimes it will go down and it will rain all of a sudden, so it will gonna affect the time it boil, because the surroundings change. Okay. And yeah, that's it. The factors affecting precision. There are other factors, but I just selected the three factors. Okay, so what is the aim of science when it comes to reliability of measurement? Of course, the aim is to have high accuracy and high precision. That's our aim, but I would like you to know that there's no perfect measurement, right? It's hard to achieve that perfection when it comes to measuring um, certain things or certain physical properties of our, let's say, substance or matter. Okay. So a measurement is reliable if it's both accurate and precise, close to the true value and consistently repeatable. If it's precise but not accurate, you're consistently wrong. Like for example, you miscalibrated instrument, you get the same result, but yeah, it's away from accuracy because it's not giving you the right measurement. It's accurate but not precise. You sometimes hit the right value, but your results are all over the place. So it's not really that good because at some point you hit the right accepted value, but uh, other than that, the values being generated or recorded are spread all over the place. Okay, so that's it. I hope you learned something from our resource video resource today or tonight or, or or this afternoon, whatever time you're watching. See you in another video.